Hello girls. So we are going to calculate the bearings of each of these points from A. A is our starting point, A is the from. Calculate what is the bearing of these places. So I'm going to use this protractor here and I'm going to bring it on top and I'm going to, from A, put that little dot on A and find my north that I'm given here, make sure my protractor lines up with that. And I'm going to calculate, look at this and say, okay, well, always going clockwise, remember, from the north line to this line, which is the path to D, point D, I'm going to look up that angle right here where it crosses, and it's about 44 degrees. So that is my answer. D is on a bearing of 44 degrees from A. Now, if I want to figure out my bearing of B from A, I start with the same thing, start off of north, and go all the way around till I hit that blue line, and figure out, looking at where the line crosses the protractor here, and I can calculate that that's about 12, let's say 112. That's about 112 degrees, right? So 112 degrees is my bearing of B from A. And keep going. How about E? E is cute. E is a semicircle. See how it's actually the same black line as the north line, just continuing on all the way down? So we know automatically as a semicircle that that is 180 degrees. That one's a straightforward one. But let's look at our green. This is where it starts to get interesting. So the green, again, start from north, calculate it all the way around, measure it all the way around, up, keep going past that 180 till you hit the green. And if we look at where it cuts, I'm looking here now at this outer number, the 240 to 250 here. So I'm actually looking at 246 or so degrees, all right? The other way you could get that is you could look at, know this is 180, right? The semicircle is 180, and only look at this portion here of, starting with 0, see the 0 here? 10 up to 66. So I could potentially do that by doing 180 plus 66, and that's 246. Same answer as this. I think you've got the rhythm now. Let's do the purple. Even though it seems closer to go this way, we're not going to do that. We're going to go the other direction, again, because it always has to be clockwise, and where it intersects is here at 312. So that's 312 degrees. Okay? Oh, that was fun. Now if I take my protractor out, you can see it this way, and you can see carefully, if you look at it, right? This is my red piece, but my blue piece is greater than 90, right? And so forth. So now we're going to find the same bearings, use the same diagram rather, to find the bearings of A from the other points, okay? So what that means is we need to take our protractor and we're going to bring this up and make it nice and big. And remember, it has to be off of north. So I've got to get a parallel line of north off of this D, okay? Does that make sense? And I need to draw that. So I need to say that I know this is north here. I need to draw that line down. And off of D, then I'm trying to get, again, going clockwise, I'm trying to figure out what that is. So I put this on here, and I measure it, and I find where that red line crosses, and that's approximately 224. Do you see how that red line, right, all the way around, hits here at 224? So that's what this is now. It's 224. So this is 224, so the bearing of A from D is 224 degrees. Same thing with B. If I want to get a bearing off of B, of A from B, I'm starting from the B, measuring here. I need to pick up with my my north. I need to find a north. I need to draw that line, okay? Draw it down. Remember, these should all be parallel to each other. So all these north lines should be parallel to each other. And then I need to calculate, if I come off of B, say B is right there, okay, what is that? Again, clockwise all the way around. Looking at the blue line, where does it intersect? It's 292 degrees approximately. 292 degrees. Do you see how that's changing? And we'll keep going. I need to get my protractor out of there. Okay. E. Now, this one's fun. If I'm going off of E, and this line is north, and I'm going to A, and it's on a north bearing, what do you think that bearing is? I'm going to go basically nowhere. It's the same place, right? Or all the way around back to, it's a bearing of 0. True north, 0. Okay? So that one's pretty straightforward. That's just 0. Okay? Next. F. Notice how, again, I keep having to do this. I've got to get a north off of this. So there's my north line. I'm going to draw that line down, put my protractor on it, and I need to find my bearing of the green line. Look where it intersects. See that value? I'm looking at about, 67? 67 degrees. And last but not least, G. Find my north, draw my parallel north line down, label it. Always good to label it north so we know where north is. Come back up, place my protractor where it needs to be, and I need to figure out, now I'm on my purple line, where does my, always going north, always to the right clockwise, where does that intersect? It's about 135. Okay. So what I really want you to take away from this, ladies, is this whole concept of your from, right? The from is what you're measuring on, is the place where you're measuring. If it's of A from B, I'm measuring on the B. If it's of B from A, then I'm measuring this, 112 degrees. The from M, A is where we're measuring it from, okay? Always draw your parallel north lines. Always good to do that. Always measure going to the right clockwise, to the right clockwise, 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 clockwise. Regardless of which direction your bearing is, if we're going from left to right or right to left, you still always come off of the north line in a clockwise direction. Okay. Now in class, you're going to do some problems with this.